Alright, so this is my robotic arm. It is not the greatest robotic arm ever, it's got heaps of wobble, but it is an attempt. And the whole goal of this was to make a robotic arm, as I've done here, without using other people's work as references. So I did all of this without looking at other people's designs, sketches, 3D models. All of this was designed by me and coded and programmed by me. I obviously used the libraries for like the servo motor control and that, which I didn't program myself, but the main program was programmed by me. It is controlled by this PS5 controller using an ESP32. Usually with my robotics projects, I don't actually finish anything. I never finalize or actually make a product. Usually I mess around with some concepts that I liked or just certain parts of a project and never finish it. In this video I was attempting to change that by making this robotic arm without any help from any other sources. It's taken me way too long to do this because I could have been getting distracted with other projects, which I can hopefully also make videos on. But this is just the number one and first attempt to prove to myself that I can make these robotic projects, especially since that's my goal in life as I've just gotten into my electrical electronics degree, and hopefully can transfer into honours with robotics at my uni. Alright, after much trial and error, we've got the prototype working, and I can control it with the PS5 controller now. So, I am doing a no-no though. It is currently powered, all the motors are being supplied power by the ESP32, which is strongly discouraged in most cases. I should be using external power from a battery pack or power supply, but I couldn't be bothered setting that up, so I'm risking blowing up this motor. Sorry, this microcontroller by being an idiot with this. But I got it working. I wasn't happy with that. Beautiful. The first prototype is now complete of the robotic arm, and it can be controlled with the PS5 controller. So all you have to do to get it to connect is you just press the PS5 button, and it should flash and connect using Bluetooth. Eventually. It's trying. There we go, it's connected. And now we have control of all three motors at the moment. We can control all, we can make it wave. And then we can also do this. And it's zeroing all of the motors to 90 degrees, well, zeroing, putting them all at 90 degrees, and just shows me that all directions of the motor are working and there's no issues with the motors. There we go. And then we can go back to controlling it all. So that's that first part done. Now all we have to do is design the wrist and the claw that's going to pick things up. That's the next step. Here is just a quick time lapse of me taking apart and putting some new parts onto the robotic arm. Nothing really interesting is happening here. I just recorded and thought I would use it anyway. So we've made some progress with the robotic arm. I've upgraded the base so it's got less wiggle in it. It's not completely fixed, but it's got less. And I've upgraded the programming. So before, how I had it just as a trial was when you move the joystick all the way to one direction, it would be 180 degrees, and if you moved it all the way to the other direction, it would be 0. So whenever the joystick was in the center, it was at 90 degrees exactly, and it wouldn't save the position. But now it feels a bit more natural because you can move it around and it will stay in the position you leave it. So wherever you have it, it saves that position of the servo motor. And then if you want it to all go back to 90 degrees, you can just press the PlayStation button. And I've still got everything working, including the wave feature, which it'll wave and then it will still put the arm back in its original position. So it'll go back to where I had it originally. So this is currently a lot better than it was. And now, what I've got left is the pincers to pick things up, which I'm currently working on now, but I got sidetracked with the code. But yeah, that's the next step, is to make a claw, pincer, hand, whatever you want to call it, to pick things up. Alright, so I've done pretty well with the robotic arm so far. I just need to do some basic tweaks on the first model to get it to be a bit more stable and have less backlash. But I now have discovered my biggest issue with making this robotic arm, which is I don't know how to make a claw or a hand or whatever you want to call it to pick things up. I have no idea, never attempted this before, and I am really stumped. I'm still sticking to the idea that I don't want to look at anyone else's work, so I have to figure this out for myself. It is a lot harder than I thought it would be, but we're making progress. This is the design so far for the claw slash hand that will pick things up on the robotic arm. It's just a basic gear system. When I turn this gear, which I'm going to call the driving gear, it opens and closes the fingers. You can do that. So this will be driven by a servo motor as well. And I'm going to put this in a little housing. I'm probably going to shrink these gears because they are a bit big to put on the end of the arm. The arm's not very, the motors aren't very big, so it can't support too much weight on the ends. So I'm going to shrink this and hopefully it will fit quite well in the end. I also want to redesign these fingers so that they can actually grip stuff, because at the moment if I try to pick something up with it, let's get something light. So if we try to pick something up like that, it doesn't have much grip, so even with just my finger, it's not holding on very well. I'll pick it up, but I can drop it really easily, so I need to redesign those to pick it up a bit better. But so far, that's the design we're going with. So we ran into a couple issues with the robotic arm where it was unable to, from the shoulder joint here, it did not have enough torque to move the arm when it was at full extension with all the parts connected, like that. So when it was out here, it was unable to move it all the way back up due to the lack of torque. So my original plan was to put a gear ratio in, so put a smaller gear on the servo motor and then add a bigger gear on to the arm. That way it increases the torque, but it slows the movement speed. So you get finer control at a slower speed. So I did a couple tests with the gears. So this is a 3:1 gear ratio between these two. You can't really see the gear in that one. But then I realized there's an issue. The servo motors I am using only rotate 180 degrees. So if I connect a small gear to the motor and it can only turn 180 degrees, that means the big gear will turn roughly just under a third of a turn, I think it is. Not sure exactly, I didn't really test this. But it will not turn 180 degrees on the big gear because of the size difference. So to fix that, I would need to use a motor with a motor controller that I can, like a H-bridge motor controller, which I have, but I didn't exactly want to add another controller onto this robotic arm. This is just meant to be a first attempt without complicating it too much. So what I've gone and done is I went to a store near me, J-Car, and I purchased a bigger servo motor. So the torque on this is 11 kilos from a centimeter away from the what's the drive point? I don't know what it's called. All I know is this, a centimeter away from the center, it can lift 11 kilos. So it should be more than enough to move this arm, even with some weight on it. Problem is, that means I have to redesign this base to fit it in, because this is quite a bit bigger. So we now have to fit that in, redesign the shoulder joint so it connects, and hopefully that means we'll have a more secure and more stable arm, and it'll fix this wobble. Alright, so now we're going to make the robotic arm pick up a pen, or whiteboard marker. Well, we're going to attempt to. The controls are still a bit sketchy with the PS5 controller. I'm probably not going to do much to change them, honestly, because I kind of want to be done with this project for the moment until I can add a bit more knowledge on what I'm doing. Surely it can reach. Straight. Yes. No. Okay. Can it lift this pen? It needs some grips or something on it. It can't hold very well because it's just a normal PLA, so it doesn't have much grip strength, and it doesn't have, it has very little friction, so everything just slides out. What else can we try? A battery? With some tape on it? Well, it really has no friction. I think the teeth are slipping. There you go. Try that. That's a bit better. Nope. Okay. Yes, I got the paper. Thank you. And put them back to the center. Here's one for holding small little notes, so I guess I can make him pass notes to me. Surely we can get him to pick up the keys, right? Let's get one of the bigger loops up near the top. Let's see if I can't. Yeah. Yeah. So you can hand my keys to me. Well, thank you, sir. Well, that was a good test.